this is the essence of this chapter, the Fourier series. Okay, 4.3. Fourier series for periodic function fx. Okay, so the Fourier series for fx is given by this expression here. So fx equals a naught over 2, blah, 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 so on and so forth. Okay, so the three things that important to be highlighted here is the a naught, an, and bn. Okay, so this a naught is given by this formula. Okay, an is given by this formula, and bn is given by this. Okay, where L, you can see the notation L is the t over 2, where t is the period of the periodic function. All right. So students before this need to memorize all of this. It's not given in the list of formula. But luckily for you guys, since you are going to have the online exam, meaning that you can have all the notes, resources, textbooks around you. So this is not compulsory now to memorize. Okay, so you can write nicely, put on the wall where you want to have your exam later. Okay. Okay, so I denote this one as equation 1. Okay, so what we have here, okay, the whole thing here is called the full range Fourier series. Okay, the general formula for the Fourier series. All right. Okay, now let us explore more on the fx. Okay, now if fx is an even function, so basically in the exam, okay, so you were given the function fx, and your task is to get the Fourier series of fx. Okay, so now if you know your fx an even function, okay, if you know your fx an even function, then you don't need to compute the bn here. Okay, bn is 0. Okay, so the justification is here. Okay, so now if fx then even, so now, okay, fx here is the even. So you multiply with the sign. Sign is the odd. So even times odd will be odd. So the whole thing here will be odd. So again, back to the integral property of the odd function. If you integrate the odd function from negative L to L, then the answer will be 0. So the whole thing here will be 0. So that's why if f is the even function, then you don't need to compute the bn. Okay, you can discard the bn, but you still need to compute the a naught and an. Okay, so in general, a naught is given here. Okay, the 1 over L integral from negative L to L fx dx. Okay, but if fx is the even, so see the effect now. If fx here is the even, then you know that when you integrate the even function from negative L to L, it is equal to the integral of fx from 0 to L. Half part, but we need to multiply with the 2. Okay, so that's why we have here a naught now is the integral from 0 to L, but we need to multiply with the 2. Okay, but over here we have 1 over L in front, so multiply with the 2, so we have 2 over L. Okay, so integral from 0 to L. In the general, it is a negative L to L. Here, it is from 0 to L, but we need to multiply with the 2. So the same thing for the an. In general, it is from negative L to L. So if fx here is the even, multiply with the cos. Cos is also even function. So even times even will be even. So the whole thing here will be the even. And then the integral of even function from negative L to L is equal to the integral of the half part only, but need to multiply with the 2. Okay, so the whole thing here I denote as equation 2. Okay, so this is the formula 2. Okay, the formula if fx is the even function. Okay, now let us see what happens if fx is the odd function. If fx is an odd function, then a0 and an is 0. Two things are 0 here. So the only thing that's left on the Fourier series formula is the bn. Okay, so this is the only thing that left. Okay, because in general, this is this one. But since a0 is 0, an is also 0. So the only thing that you have is here. Okay, with a summation notation here. Okay. So again, okay, let us see the justification why a0 and an is 0. Okay, so now this is the general. So now if your fx is an odd function, again back to the property, the integral of odd function from negative L to L is 0. Okay, the same thing here, fx is the odd function, multiply with the cos which is even, so odd times even is odd. Again, the whole thing here will be odd, so the integral of odd function from negative L to L is 0. Okay, but for the bn it is not 0 because this fx, okay, now fx is odd times the sign which is also odd, so odd times odd will be even. So the whole thing will be even, so the integral from negative L to L for the even function will be equal to the integral of half part, but need to multiply with the 2. Okay, so this is formula number 3. So to summarize, we have 3 formula, 1, 2, 3. So in the problem, if you can recognize that f is the even function, then you go straight to the formula 2. If you know that your f is the odd function, then you go straight to the formula 3. But if you don't know, then you need to do the general one. Mean that you need to compute all of them, a0, an, and bn. Okay, so sometimes students ask, what if the student want to concentrate on Formula 1 only? Don't want to know about Formula 2, don't want to know about Formula 3. So my answer would be, yes, you can do that. Okay, but most likely in the exam you will waste your time. Okay, because you take the example, if in the problem the given function that is given to you is odd function. Okay, so if you don't look at the formula number 3, then you will waste your time computing the a0 and an just to find at the end they are all 0. Okay, rather than go straight, okay, to the formula 3, just compute the bn. Okay, so you will save your time over there. Okay, so that's the Fourier series formula. So basically we have 3